Hi everyone, I'm Yuki. Today we are going to understand the beating heart of Bitcoin, something called the UTXO, completely from scratch by actually clicking through it on screen. Here is the punchline up front. Bitcoin's ledger has no accounts and no balances. What it has are UTXOs, unspent transaction outputs. Think of them as discrete pieces of money, like cash bills, that were created by a transaction and haven't been spent yet. This money itself gets spent, disappears, and is reborn as change. We'll experience that strange, elegant idea in 6 steps. You can jump between chapters with the tabs. Then, let's dive in. Let's start with the fundamental question. Why does Bitcoin even need such an elaborate design? The answer comes down to one single problem: double spending. A paper bill can be handed to 2 people at once. Physically, there's only one of it. But digital data can be copied endlessly. If you could send the exact same coin to both Bob and Carol, money will be worthless in an instant. Let's send this unspent UTXO to Bob. Send to Bob. The UTXO Alice was holding is now marked spent, and it's removed from the ledger. Money that no longer exists. Now let's try to send that same coin again, this time to Carol. Send to Carol, and blocked. That UTXO doesn't exist anymore, so the network simply refuses it. Bitcoin doesn't chase the money itself. Instead, every node shares one record of which coins are still unspent, and that's how double spending is prevented. This is the starting point for everything else. So, if there is no balance, how do you actually pay? Let's look inside the wallet. Now 0.5, 0.3, and 0.2. Just like cash, you simply hold a few UTXOs. Let's try to pay 0.6 BTC. There's no exact 0.6 bill, so we pick the 0.5 and 0.3. That's 0.8 total. With cash, you'd hand over more and get change back, right? UTXOs work exactly the same way. The bill you pick becomes the transaction's input, and you can spend half a bill. They are consumed whole. So when we send, the brand new UTXOs are born. The 0.6 that goes to Bob and the 0.195 that comes back to you as change. And 0.005 is fee in this demo. The old bills are gone. The change returns as a new bill. There's exactly one rule. Inputs equal amount paid plus change plus fee. But where does that very first bill come from? Trace any UTXO back far enough and you reach a mining reward, the Coinbase transaction. It's a one special transaction with no input. It's where new Bitcoin is born. From there, each transaction's output becomes the next transaction's input. On and on. That chain of references is literally the chain in blockchain. Next question. How do you prove a coin is yours? A UTXO carries more than a amount. It carries a lock. and engraved on that lock is the owner's fingerprint, technically a public key hash. To spend, you present your public key and a signature. The network checks three things. 1. Compute a fingerprint from your public key. 2. Does it match the fingerprint on the lock? And 3. Is the signature genuine? All three pass and it opens. Then let's try. Try to open. Like this. Now, what about the long key? Long key. Now, let's try. Try to open. And it fails at step 2. The fingerprints don't match, and the lock stays shut. Only the person who truly holds the private key can open it. By the way, that lock is really a tiny program called Bitcoin script with no loops or recursion. If you are curious, open the advanced panel and you see those same 3 steps map directly onto the opcodes. Now, here is how an address fits in. An address is just that lock fingerprint written as a human readable string. The path is one way: private key, public key, fingerprint, and address. And the key point is one private key gives you exactly one public key, one fingerprint. One address or 1 to 1. Private key, public key, fingerprint, and address. So, why can you have many addresses? The branching happens earlier at the seed. From one seed, those 12 to 24 words, you derive separate private keys, each with its own public key and address. They look different, but they are all yours. That's why your balance is simply the sum of the UTXOs locked to any of your addresses, and using a fresh address each time. That's for privacy. Let's zoom out to the big design difference. Bitcoin is cash, UTXO. Ethereum is a bank account. This single choice saves parallelism, privacy, and smart contracts all at once. Now, let's fire off 4 transactions from the same sender. Send 4 transactions. The account model updates one number, a balance. So, for safety, it must process them strictly in order. Each transaction carries a nonce, a counter, and if nonce 2 arrives before nonce 1, it just waits until nonce 1 is done. It isn't invalidated, it's queued. UTXOs, on the other hand, are independent when they spend different coins, so they can be processed in parallel. You also get easier privacy from using a fresh address each time. The trade-off is shared state. Smart contracts are harder to express. Now let's get practical. When you pay 0.5 BTC, which UTXOs should you use? The number on the right of each coin is its net if spent. Its value minus the fee for one input. Look at the bottom one. The dust. It's only 0.0003, but spending it nets minus 0.0002. The fee is worth more than the coin itself. So, on its own, it's effectively a negative asset. Fewer inputs mean a smaller fee, covering 0.5 with just 0.3 and the 21 gives you the minimum fee. Let's add the dust just to see. The gauge grows and the change actually goes down, like this. It really does cost you. But that isn't hopeless. When fees are low, you can sweep up your small coins into one. That's called consolidation, and cut your future waste. Finally, the present. Every full node holds the entire UTXO set, a complete list of all the money that exists right now. And that set nearly doubled from about 84 million at the end of 2022 to about 169 million in 2025. And here is what drove the spike. Ordinals launched in January 2023 and the BRC20 in March. Ordinals numbers individual satoshis and inscribes images or text onto them, essentially Bitcoin native NFTs. And BRC20 builds tokens on top of that using text encryptions. Both mint floats of tiny UTXOs, so the set ballooned and fees spiked. Through upgrades like Taproot, the UTXO keeps moving like cash to this day. And that's the foundation and the history of the UTXO. So, to recap, Bitcoin's money isn't a balance, it's individual UTXOs that are spent and reborn. Ownership is proven with keys, and everything is linked by a chain that begins at the Coinbase. Once that picture clicks, the rest of Bitcoin gets a lot easier. You can run this demo yourself from the link in the description. If it helped, a like and a subscribe go a long way. See you in the next one. Bye.